Hey everyone, all right, welcome back. Let's finish off this unit. So today we're going to be looking at types of functions and trying to identify them from tables, equations, and graphs. And we're also going to do a quick dip into average rate of change, also known as slope, between 2 points. And you'll be asked a couple of questions about that in this unit, in our unit test, because it will be helpful in identifying different types of equations and then comparing equations as well, and functions interchangeably. So essential questions for today: how can you use your calculator, that wonderful calculation tool that you should have, to determine the type of function when you're given a data set or a table? And then what does it mean to find the average rate of change between 2 points? What is slope? All right, so types of functions. First one up is a linear function, which is the one we should be most familiar with. Key characteristics: it appears as a straight line. So there's no turning points. It does not vary from that straight line in any way. So you can put a ruler up against it and you will get that function. So if you see a straight line appearing anywhere, you're probably thinking, okay, linear function. Next up, if you look at the table of values, so if you're given either a series of coordinates or in a table, so x value, y value, as the x goes up, so this one went up +3, the y value went up +2. If I go to the next one, it went up +3 again, and the y value went up +2, and +3, and +2. So the key is the x values might go up by different amounts, but the y values are going up consistently by the same value. So like, if I'm going up 3 for x, I'm going up 2 for y, 3 for x, 2 for y, 3 for x, 2 for y. So if I went up a jump of 6 for x, I would expect the y value to go up 4. So that rate of change, what we're going to talk about in a few minutes, is consistent. And then looking at the equation side, what you'll notice is that equation form, y equals mx plus b, is a common way of seeing this. So you'll see something, the slope, times an x value plus a constant. In function notation, it's going to look the exact same. So in this one, we can see the slope is 2/3. That's my m value. There's an x, and then there's a constant of 1. And that constant is also the y-intercept, which is kind of nice to point out. So y-intercept of 1, we can see that in the graph, and then slope of 2/3, that means we're going over 3 up 2. And some other things to point out: the highest exponent value we'll see in x is x to the power of 1. So you won't see x squareds or cubes or anything like that. You'll see x to the power of 1 is the highest exponent of x. Next up is quadratics. Quadratics, typical shapes are U shapes or N shapes, and we would say the shape of this is a parabola. So it's not a true U, which would have vertical lines, or an N, which would have vertical lines. This is a parabola shape, so it can be opening upwards or downwards. This one, the example, opens upwards. So things to note: you'll see that it comes down, it turns once, so one turning point, so there is a vertex, and then it goes back the other way. So there's either going to be a max or a min in the graph. If we're looking at the table of values, one thing to watch out for is repeating values for the y. That means that there's 2 different x values that have the same y value, which means that it has turned back on itself at some point. Noticing that it's going down, so it's -6, then -2, but then +2. So we're noticing a change in the way the y value is shifting, even though the x value is consistently going up by 2. So the x value is not changing, but the y value is. So that tells you it's not linear and that we need to think about something else. So quadratics would be a great explanation for that. In terms of the equation, you'll see it in 2 different formats. So this one is vertex form. It has a h and a k value, and those line up with our vertex. So 2 and -2. So that's where the 2 and -2 are coming from in the equation down here. You also have general form. So this is the one that is probably more commonly seen in Algebra 1. So it's going to be something x squared, something x plus a constant. And the constant, again, is the y-intercept, which is always nice to know. So then what's different to a linear equation is that there's an extra term. There's 3 terms in this one. And it doesn't have to be 3 terms, by the way. So sometimes this term or the constant term can be missing. But the key thing is that the highest exponent of x is 2. So when you see 2 or x squared, that tells you quadratic. If you see a 3, it would be a cubic, but we don't have to go into those just yet. All right, next one up is exponential. We're not going to deal with exponentials too much right now. That's more of an Algebra 1B or later in Algebra 1 if you're doing 18-week algebra. But just some things to note. It's something that grows by a percentage or decays by a percentage. So we have growth and decay. So if something is doubling, tripling in value every step of x, then we would say that's exponential. If it's being cut in half or thirds, also exponential, that's exponential decay. So like your money will grow exponentially if it's invested. Medicine in your body will decay exponentially after you've taken it. Some things to look out for, you'll get a kind of an L shape on the curve. It'll start really slowly and then it will quickly climb, or it'll decline really quickly and then slow down. So you get this kind of L shape. It can be inverted. So like, don't be alarmed if it doesn't quite appear like any of these, but you're looking for steep, dramatic changes in slope and then more shallow parts as well. Doesn't turn back on itself, so it's not going to ever come out with a U shape. It'll cap out at an L. And then table-wise, look for multipliers. So like 0.5 to 1, it's going up 0.5, and then so plus 0.5 plus 1 plus 2 plus 4. So looking at that 0.5124 or 0.51248, like they're doubling each time. 0.5 times 2 is 1, 1 times 2 is 2, so it's actually times 2 each time. So if you can see that happening, that sort of pattern, that it's multiplying by something each time, and that something is staying consistent, that tells you that you've got an exponential function. So the way the equation part is set up is you have a starting value, you have a rate of change. So in the example given here, the rate of change is 2, so it's doubling. And then to the power of x, so our x, so our independent variable is actually in the exponent, not in the kind of the main level of the equation, so it's in the superscript. And then h and k are ways of moving it right, left, up, or down. So in my example, f of x equals 2 to the power of x. There is no h or k value, and there's no a value. So it's starting at a value of 1, which is why 0, 1 is a point. And then it's doubling every time we take a step on x. So you go out 1, it's now at 2. You go out to another one, it's at 4. Another one, it's at 8, and so on. Last one we're going to look at is absolute value, characterized by its V shape, and the V can be opening upwards or downwards, but it's 2 linear functions together is how it kind of appears. And you just want to be careful, and we don't really need absolute value right now, but the reason I want to throw it in here is that some people can be tricked into thinking this is a linear equation when they check the table if they don't do the whole thing. So like if you checked the first 3 terms here on the table, you'd be like, okay, I went up 4 on x, and I went down 3 on y, and then I go up 4 again, down 3, and you're like, oh, it's consistent, this is linear. But then you hit the next point, 6, and you're like, oh, okay, I went up 4 again, but this time I went up 3 instead of down 3, and then plus 4 and up 3 again. So it's not a consistent rate of change. The rate of change actually inverts, so it goes the other way. So you want to watch out for that V shape, and the equation is very easy to recognize. It's got these 2 vertical bars in there. Not number ones, they're vertical bars, so that's absolute value. So our function here would be 3/4 times the absolute value of x minus 2 minus 1. So the 3 most common ones you're going to be asked about are linear, quadratic, exponential. Just a little summary. Equations-wise, you'll have x to the power of 1 is the biggest, x to the power of 2 in quadratic, x in the exponent for exponential. Constant rate of change, so the slope stays the same. U-shape or N-shape for quadratics, that curved L-shape, or noticing a multiplier in the rate of change as opposed to it being constant. And then from an end behavior point of view, end behavior goes opposite directions for linear. Quadratics, it will go the same way, so both up, both down. And in exponential, one side will go to positive or negative infinity, the other side will approach a horizontal value, so probably like 0 or something else. It's called an asymptote. All right, different scenario, you're given a data set and you're asked what type of function is this? So we can make a table out of it and we could say like, okay, let's check and see. So -3, -2, -1, so the x's are going up in ones, and the y values, this one went down 13, and then from 15 to 8 it went down 7, and then 8 to 7 it went down 1, and then it went up 5, and then it went up 11. So it's been going down and then coming back up again, so it's not linear because they're not all the same, and some negative, some positive. It could be absolute value. We're not typically seeing that. I'm not seeing ones matching up here, but it could be. It cannot be exponential because it went down and then back up again, which we wouldn't see in exponential. Exponential will either continue to grow or continue to decay towards a point or from a point. So you won't see it like come back on itself again. But if you're not sure, the best way to do it is to graph it. And a quick way to do that is with your calculator. So one thing I want to show you is the steps for doing that. So step 1, you got your calculator out. You're going to hit the stat button. So the stat button is up in it's on the 3rd row from the top. So near the arrows on your calculator is the stat button. And you're going to plug in the x and y coordinates in L1, so that's list 1, and L2, which is your list 2. And you're going to make sure they match up with each other. So -3 goes next to 28. So like in the image, you can see that first step, L1 and L2. So we got them listed out. And then second step is to hit zoom 9. So the zoom button is on the top row. You can see it in the center there. And 9 is zoom stat. It's going to adjust the window, so what you can see on the graph, to fit all of the stats in. So zoom 9. And then from looking at those dots, we can see, oh, this has got that classic U shape going on. This is a quadratic. And that's a very easy one to identify typically. So calculator, very helpful for doing that. The regression model, so you may be asked for a line of best fit at some point. We'll get to that a little bit later, so I'm going to ignore that one for now. But yeah, put into your calculator in stat, x and y values, and then zoom stat. One thing to note, you need to make sure that when you go into your y equals button, that stat 1 is turned on. And in some of your calculators, it'll be represented as plot 1. So just be aware of that. You want to make sure that, and it'll look like it's a black box around it. So like it'll invert the color when it's turned on. So if you're hitting zoom stat and nothing's popping up, it means that you probably need to go into the y equals button and turn on plot 1 and then hit your zoom stat again. Also, make sure that there's no equations in there. So clear out any old stuff and then do your zoom stat again. All right, average rate of change, also known as slope, which is also known as the change in the y values divided by the change in the x values between 2 points. Also known as the rise over run. There's a lot of different ways of calling this thing. Equation-wise, make sure you write this one down. This is one of our most important math equations, and you will be using it again in geometry if you're taking that next. So y2 minus y1 divided by x2 minus x1. And that refers to 2 points. So you'd have 2 coordinates, x1 and y1, and then x2 and y2. So 2 points on the graph. And that's where those numbers are coming from. So like the y2 value would go in here, the other y value would go in the first one, and then you would calculate it out, and that would be your slope. We'll do some practice. All right, so you got 2 points, A and B. What is the slope of the line connecting A to B? When it's on a graph like this, it's actually really easy, you can just count boxes. So if you were to draw the line between them, you can say, okay, this went down 1, 2 boxes, and then over 1, 2, 3, 4, 5. So when we think of it as rise over run, down 2 is minus 2. So the rise decreased. And then the run, we went over 5, and that was positive 5 from left to right. So the slope of this is minus 2, 5. But let's do this with the equation just to see. So it doesn't matter which point is y1 or y2, but we'll go with A first. So A is at minus 2, 4. So this is going to be my x1 and my y1. And B is at 3, 2. This is going to be my x2 and my y2. So the first x values and y values, the second x values and y values. And let's sub in our numbers. So y2 is 2 minus y1, which is 4, all over x2 is 3 minus, now x1 is negative 2. So you have to watch out for that. There's going to be a double negative situation here. So this is actually going to be a positive number. So 2 minus 4 is negative 2. 3 plus 2 is 5. So there's my slope again of minus 2 over 5. Another way you'll be asked this question is you're given the graph or you're given the table. Not sure which one you'll be given, but you can do it with either of these and I'll show you. Interval 0, 3. This, if you're given an interval, guys, this is not a coordinate. This is referring to a domain interval. So x values. So from x equals 0, we don't know what the y value is at the moment, to x equals 3, don't know what the y value is. I have to fill in these blanks to get my 2 coordinates. So on the graph, you go to 0, you would say, okay, the y value is 1. At 3, the y value is 8. So I'm actually being asked, what's the rate of change or the slope between those two numbers? If I go to my table, at 0, I can see 1, and at 3, I can see 8. So those are my pairs. So our formula, again, y2 minus y1, x2 minus x1. So I've got 8 minus 1 over 3 minus 0. So that'll be 7 over 3. One thing to note, positive slopes means that it's going up from left to right, as it should be. So from left to right, the slope is going up. In our last example, the slope was negative because it was going down. So positive is up, negative is down. All right, we have a quadratic. What's the average rate of change from f of minus 2 to f of 2? Just a different way of asking this. So f of minus 2, remember this is our x value. So we have to evaluate the function for minus 2 and also for 2. So when x is 2, the y value is minus 2. So there's 2, negative 2 in our table. And when x is minus 2, the y value is 6. So looking at this from left to right, my slope should be negative. So one thing to note, should be negative. And I'm going to count boxes for this one. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8 down. So it's a rise of minus 8. And then it's going to be over 1, 2, 3, 4. And minus 8 divided by 4 can be simplified. So 8 and 4 are both divisible by 4. So that'll be minus 2 over 1. So an average slope of minus 2. So in the beginning, it's a bit steeper, but at the end, it's a little bit more shallow. The average rate of change is minus 2. And we can check that with coordinates again. So that would be y2 minus 2 minus 6 over 2 minus negative 2. So that'd be negative 8 over, it's going to be a plus, so 4, which simplifies to minus 2 over 1, which is the same as just minus 2. So slope of minus 2. All right, that brings us to the end for today. How can we use our calculator? We can use the stat function. So it's stat, put in your L1 and L2 values. L1 is your x, L2 is your y, and then hit the zoom stat option, and that'll give you just a picture of where all of those coordinates are, and it can help you determine what type of graph you've got. And then what does it mean to find the average rate of change between 2 points? You're being asked to find the slope. How does the y values change divided by the x values? And we're always talking about from left to right. Okay, for tonight we got a lot of Khan Academies lined up to try and help prepare us for this unit test. Let's make sure we're trying all of them and trying to get that minimum score of at least 60. See you all soon.